Hello students! In the previous video we just learned about the rational roots theorem, which gave you a list of all the possible zeros, all the possible roots for a polynomial. But some of those numbers were positive and some of them were negative. So now we're adding to that Descartes' rule of sign, which will tell us how many of the zeros are positive and how many of the zeros are negative. How many answers, because you had that long list of possibles. Now we're going to narrow it down some. Okay, so this is going to tell us how many positive or negative zeros a polynomial has. Here's what you have to do. You're just going to count the number of sign changes that occur as you go along the polynomial. And then the number of zeros is either the exact same number as the sign change, or it could be an even number less than the sign change. So if you're counting the sign changes and there's 5 sign changes, well then how many zeros does it have? It either has 5 zeros or 3 zeros or 1 zero. So you count down by 2's, an even number less. Okay. And then if you want to find out how many negative zeros the polynomial has, then what you're going to do is you're going to replace x with negative x. And then you count the number of sign changes the same way as before. So let's look at an example of what I mean by that. Okay, let's see what I mean. What do I mean by counting the number of sign changes? We're going to look at each term in the polynomial and decide if it's positive, if that particular term is positive or negative, and then if there's a change from the first term to the next term. So it looks like this first term here is a positive number. It has a positive 3. Let's just put a plus. Okay. Even though there's not really a plus there, that's a positive 3. Now, we're going from a positive value. And then the next value here is a negative 2. So it looks like we just changed from positive to negative. So this here is a change. Now, going from this one, this here is a negative 2, and we're going from a negative 2, and the next value over is a negative x. So this time we started at a negative, and we're going to a negative here. So it stayed the same. We stayed with the same sign. That was the same. How about the next one? Is it a change or is it the same? I'm going from negative x, and then I'm going to a positive 7. So I'm going from a negative to a positive. So that is a change. And then here I'm going from a positive to a positive. So that's the same. And here from a positive to a negative, a change. Okay, so it looks like this particular polynomial had 1, 2, 3 sign changes. Since it has 3 changes, that lets us know that there are 3 positive zeros. Okay. Now, it could either be 3 zeros, or let's count down by 2's from there. There's 3 zeros. It could also possibly be 1 zero, because 3 minus 2 would give me 1. Okay? Let's count the sign changes on the next one. I go from a positive value to a positive value, so that stays the same. Then I go from a positive to a negative, so that is a change. Okay, now I'm going from a negative to a positive. Again, another change. From a positive to a negative, another change. And from a negative to a positive, change again. Okay, so this time I have 4 changes. So 4 changes means that I have 4 positive zeros. Or, counting down by 2's, going from 4, I could also have 2. 4 minus 2 gives me 2 zeros. And I can go down by 2 again. 2 minus 2 is 0, or I could have 0. So I either have 4, 2, or 0 zeros. All right, let's try the next one. I go from positive x squared to positive 2. That stays the same. Then I go from positive 2 to positive 5. Again, stays the same, stays positive. And now I'm going from a positive to a positive. Okay, still the same. Okay, so this one has 3 It stays the same every time. It has 0 changes. So since it does not have any changes, 0 changes, it must have 0 zeros. 0 positive zeros. All right, let's look at the next one. I start with a positive 4, and I go to a negative 2. So from positive to negative, that is going to be a change. All right, so this time I have 2 changes. 2 changes means that I would have 2 positive zeros. Or counting down from there by 2, subtracting 2 from 2 would give me 0. I could also have 0 zeros. Okay, now let's see if we can decide how many negative zeros the functions have. To find negative zeros, what you're going to do is you're going to replace the x with the negative x. Now, do you guys remember we've done this before, replacing the x with negative x, when we were trying to determine whether or not the function was even or odd? Just like that, we're going to replace the x with negative x. All right, so I have gone through and rewritten it, but I've replaced all of the x's with negative x's. So now, how does this change our function? Well, when we have a negative to an odd exponent, odd means that we're going to have a negative, one of the negatives is left over. A negative and another negative will cancel out, right? So every 2 negatives will cancel out to make a positive. So if you had 4 negatives, 2 of them cancel and 2 of them cancel, right? And then all the negatives cancel. So if you have an even number of negatives, they're going to all cancel. If you have an odd, if it's raised to an odd power, then you're still going to have a negative left. So right here I have negative x to the 7th power. 7 is odd. I'm going to have a negative left over. So this is going to become negative 3x to the 7. Then I have negative x to the power 5. 5 again is odd, so I have a negative left over. So my negative that's left over is going to multiply with this negative, and together they're going to make a positive. I have positive. Here I have a negative x to the power of 4. That means all of these negatives cancel out. And this negative that was in front is still down here. So negative x to the 4. Even means that all these negatives are going to cancel. So I have plus 7x. This one has no power, so it's just a negative. And here a negative times a negative is going to turn to a positive x. And then minus 3. Okay, so now that I have done that, let's count our sign changes. Okay, so how many changes do I have? 1, 2, 3, 4. I have 4 changes. That means I have 4 negative zeros. Counting down from 2 by 2, subtracting 2 from that, I could also have 4 minus 2 gives me 2. I could also have 2 zeros. Or 2 minus 2 again is 0. I could also have 0. All right, let's try one more. Let's go through this problem, and everywhere that there's an x, let's replace x with negative x. I've replaced all the x's with negative x. Negative x cubed gives me negative x. I've replaced all the x's with negative x. Negative x cubed gives me negative x. Negative x squared. That squared, it's an even exponent, so that turns to a positive. So I just have positive 2x squared. This negative does not have anything to make it cancel out. It's just negative x times 5, so that's minus 5x. All right, let's count the changes now. All right, and counting down but from 2 from there, we could either have 3 negative zeros, or we could have 3 minus 2. We could also have 1 negative 0. And that is all for Descartes' rule of signs.